So I'm happy to present today to you the PROTEUS-6G project, which is focusing on optical networking solutions for the front haul and mid haul part of the 6G networks. For those that are wondering, Proteus is a name of, according to Greek mythology, of the son of Poseidon. That's why we have at our logo the trident. And again, according to mythology, it's a creature that can take any shape. It's very flexible, as is the infrastructure we're developing in the Proteus project. So this is the consortium consisting of 14 partners from all over Europe, representing all the elements of the value chain, from operators to system vendors, to component manufacturers, and of course, academic institutions and universities. So the problem that we're trying to address and solve with our solution is the evolving front haul requirements in terms of bit rates and latency. These are becoming really enormous, especially when considering some of the possible functional splits that can be implemented at the front haul. According to discussions we have been having for the last 10 years or so, there are 8 possible options, and some of them, according to some hypotheses we can make about what are going to be the needs of 6G services and advanced 6G services further down in the future, we can make some assumptions about how to support those services of the future based on some advanced equipment at the run. Then, based on this assumption, as you can see over here, the numbers that come out in terms of the bitrate requirements for both the downlink and the uplink become really staggering, exceeding several terabits per second, actually, at the front haul, which, of course, pushes the requirements also at the mid haul and the backhaul part of the network. So how we can actually develop solutions at the front haul and mid haul that can serve these future requirements. So in our approach, in the Proteus project, we focus on the development of advanced packet optical solutions, infrastructure that can support the front haul and mid haul, that relies on programmable photonic integrated circuits for implementing both the transceiver functionality, but also switching functionality. These elements are controlled by an intelligent control and management plane, which orchestrates the deployment of the various functional splits across the network in a dynamic way, and optimizes the utilization of resources. To support the needs of the 6G front haul networks, our project develops a novel infrastructure, a novel architecture actually, for the front haul network, relying on a diverse, spatially diverse point-to-multipoint optical distribution network, implemented using programmable photonic filters. And at the transceivers, the interfaces, the RUs, and at the cell sites, we're utilizing new transceivers that implement digital subcarrier multiplexing in a flexible, dynamic way, but also some new transceivers that are extremely low power consuming, because they rely on photonic processing rather than electronic processing. And all this, of course, are controlled by our SDN controllers and orchestrators. So here you see how in our innovation area A, that focuses on the architecture of the network, you can see how the cell sites are connected using our novel ODN, optical distribution network, consisting of some new programmable elements that distribute the signals to the cell sites and collect the signals from the cell sites towards the mid-hole, where we have a ring network, which comprises of some optical nodes, some reconfigurable optical ROADMs, which are actually capable of performing processing and switching on subcarriers, on individual subcarriers produced by our transceivers. And then, of course, the signals are directed to the backhaul network and the CU pools for further processing. With our solution, we're trying to address the limitations of current front-haul solutions, optical front-haul solutions that are being discussed and utilized today. Those rely on time division multiplexing, TDMA, for the two directions of the traffic. And they also utilize some low-cost transceivers, but those are implemented based on very simple concepts of intensity modulation and direct detection, which for the future will not be able to support the needs of the network, including a larger number of users, much larger number of users, longer reach, higher capacities. So we need to find another solution to support this. Also, the current networks at the front haul are very lossy. They introduce quite significant loss, and this limits the signal-to-noise ratio and thus the capacity of the overall network. So for this purpose, we need to come up with a new implementation of the front haul optical infrastructure that resolves these problems. And this is actually what we have proposed in order to address all these limitations. So we are implementing with digital subcarriers the transmission of the signal, but then the handling of the signals, the multiplexed level, is performed by new devices. We call them circular subcarrier interlacers, replacing the existing components that are deployed in today's network, which are typically simple splitters and combiners. With our solution, we can achieve much higher spectral efficiency and reduced loss, therefore being able to support very long reach, but also much higher bit rates. And of course,
one more minute.
Excuse me?
You have 1 more minute, Ioannis.
Okay. As we move towards the mid-haul, then there we have the optical ring with ROADM nodes that are capable of performing switching and add drop of these individual subcarriers. We have verified actually the performance of our solution, and we have shown already that very high quality of the received signals can be expected, as shown here at this slide with very clear constellation diagrams, even under stretched conditions for the optical signals that are transported in the network. Furthermore, we're developing some simplified, coherent, energy-efficient transceivers based on the so-called concept of linear drive optics, which is a very hot topic currently emerging in the optical communications community. And with those transceivers, we can achieve extremely low power consumption and very high performance by removing costly and power-hungry digital signal processing chips with all optical signal processing once. And of course, all these components, the nodes, the transceivers, the combiners and splitters are now controlled with our intelligent control plane, which comprises of a controller for the packet X-Hall and also another controller for the optical X-Hall, and those are orchestrated together with our SDN orchestrator.
Sorry, Ioannis, your time is
Yes.
up.
Yes, okay. So
Do you
that's
have a final
that's all
wrap-up
then.
slide, anything you want to present, or no, you're done?
No, I have completed the discussion on the innovation areas. I just wanted to say that you can find us at the website here, and please follow us also on the LinkedIn account. So that's all. Thank you very much.